back to another video. Now, the reasons why I'm going to make this video is because we did cover differentiation in Pure 1, and in essence this is just an expansion of the knowledge and just digging deeper a little bit to understand it. So today we're first going to start with looking at differentiation. Let's differentiate 2x cubed. We said if we differentiate 2x cubed, we times the power by the number, and we said that's 3 times 2, that's 6x, and we decrease it by 1, so it's 6x squared. Differentiating 1 over x squared, we said that we change this, can be rewritten as x to negative 2, and differentiating this now, we have minus 2x to negative 3, and then converting this back to a fraction will give me minus 2 all over x cubed. So that was differentiation, timing the power, reducing the power. Okay, let's look at one more. Let's look at x to the power 2 to the power 3. We said that in differentiation we times it by the power, so 2 over 3, and then subtract 1. So 2 over 3 take away 3 over 3, which is equals to 2 over 3 x to the power negative a third. And that's differentiation. Today we're going to dig deep a little bit more, and we're going to look at some more details. So let's buckle up, get yourself ready, and get yourself ready for this masterclass in differentiation. Okay, Pure 2 kicks off with looking at increasing functions and decreasing functions. So the first thing that we're going to start with is to differentiate. Okay, differentiate. So differentiating the dy over dx, okay, will give us 3x squared plus 24. That's the dy dx. Now, to show that it's all real for increasing functions, so what that means, the function's always increasing. That means for any value x, there's always going to be the curve is actually going up. Okay, it's increasing, something like that. Okay, it's always going up. So to show that, we can prove that by saying, looking at the values 3x squared plus 24, if we place any value in x here, nor it's a negative value or it's a positive value, we always get a positive answer. Okay, the answer is always greater than 0. Okay, and that's for all values of x, because minus 5 squared is positive, isn't it? And multiplying that by 3 and adding 24 gives us a larger answer. So therefore it's all positive for any value. Okay, and that's true, and you can show it because you get 3x squared plus 24, and x squared means that it can be negative, we square it, we get a positive, so that's true. Next one is looking at a decreasing function. Again, we can't really differentiate it immediately. We need to expand and then differentiate. So 4 minus 2x cubed minus 3x. So just double check that we get the expansion correctly, and now we can differentiate. So I'm going to use the function f dash now. It means the same thing. Okay, it means the same thing. So 4 will disappear, we get minus 6x squared minus 3. Okay, now looking at this function, if I take the negative outside, I'm left with 6x squared minus 3. Now, because I'm always timesing by a minus, any value I place for x, I'm always going to get a negative value. My answers will always be less than 0. Okay, my answers would be always less than 0. Solutions, my range would be always less than 0. So we can clearly see in this question, because I take out the negative, I'm showing the examiner that any value x, any value r is always going to be less than 0. Okay, always less than 0. And because it's always a minus sign, you can put a value here, let's say 3 squared is 9 times 6 is going to be 54. 54 is positive, isn't it? But because we're timesing it by a negative, we are still in the negative values. So this exercise is all about differentiating, looking at your dy dx and then saying, okay, is it all decreasing function or is it an increasing function? Just look at it and understand it, okay? And that's literally all you have to learn for 7a, okay, or for 7a. And again, if you have any questions in exercise 7a, you do talk to me in class and we will go through it. Okay, now let's look at this function. So this is a typical graph. We have to be able to appreciate the understanding of a local maximum and the understanding of a local minimum. And that point is the inflection point where the function starts to decrease or the function starts to increase. So in a function of such nature, we have a local maximum is the maximum point, and the local minimum is the minimum point, okay, in this graph. So let's look at this question here. It says find the coordinates of the stationary points on the curve. Done this in Pure 1. By considering the points on either side of the stationary point, determine whether it's a local maximum or a local minimum. Okay. So let's look at this question. So first thing is you always differentiate. Okay, differentiate. So differentiating this, we'll have dy over dx, okay, is equals to 4x cubed minus 32. So a stationary point, when you're looking at stationary points, you always let dy over dx equals 0. So let dy dx equals 0. And we're looking for the point where the gradient is 0. That's what it means. Dy dx means the gradient. So looking at the gradient where it's 0, 4x cubed minus 32 is equal to 0. So solving this will give me 4x cubed equals 32. And we're not used solving cubics, but it's a special type of cubic, because if I divide by 4 both sides, I'm left with x cubed is equals to 32 divided by 4 is 8. And that's a cubic number. So x is equals to just 2. So now I have my answer. I've solved my dy dx. I'm going to find the d2y dx squared. So d2y dx squared. I'm going to differentiate again basically. So let's take the 4x cubed and differentiate that again. And that will give me 12x, and that's it. Okay, 12x squared, I do apologize. So now I have 12x squared. So the final step that we want to do is we're going to place this point here and say substitute sub x in d2y over dx squared. So use this as your checklist. So now we're going to take the 2. So we'll write when x equals to d2y over dx squared is equals to 12 times 2 squared. And 12 times 2 squared is greater than 0. Which means it's greater than 0. Which means, okay, x equals 2 is a minimum point. Okay, x equals 2 is a minimum point. The question wants the stationary points, the coordinates. So if we have our x coordinate, we can find our y coordinate by placing it back in this equation. That will be 2 to the power 4 minus 32 to the power 2. So it's 2 to the power 4 minus 32 multiplied by 2, which gives me minus 48. So this answer here, it's a minimum point, and the point is 2 minus 48. So let's look at this question again. We said that the question starts with differentiation. It starts, then it goes to dy dx, then goes to d2y dx, and then finally goes to subbing in the x value into dy over dx squared. So that's nice and easy. Please do slow the video down, watch the video in your time, and make sure you're covering everything. So the next value that we need to look at is going to be the next coordinates. Exactly the same thing. We're going to find first dy dx, then we are going to differentiate it by finding this solution. this will give me 3x squared minus 30x, okay, plus 24. So now we found dy dx. The note says make dy dx equals 0. So letting that equal to 0, so let dy dx equals 0. That will be left with 3x squared minus 30x plus 24. All the numbers are divisible by 3, so I'm going to divide everything by 3 to make it easy for me to factorize. So that will be x squared minus 10x plus 8 equals 0, and I can factorize now nice and easily. So x and x, and that will be well, is it even factorizable? Let me just double check it. If you got a calculator, put it in equation mode and Bob's your uncle. And I'll do the same, just make sure, because 4 and 2 and 8 and it's not factorizable to me. 1 minus 10 and 8. Yep, so it's not factorizable, like I said. So we have two values, either x equals 5 plus root 17 or x equals 5 minus root 17. So now I found my two stationary points. Okay, I can now find d2y over dx squared, which means to differentiate that value dy dx again. So d2y over dx squared, make sure your notes are nice and easy for the examiner to read, 6x minus 30. So now I have the d2y. What I'm going to do in this situation is I'm going to take each point and place it back in. So the first point I'm going to put back in is the first x1, and that will be x times 5 plus root 17 minus 30. And I'll see what the value is. Is it greater than 0 or less than 0? So mode 1, I'm going to do 6 open bracket 5 plus root 17, and I'm going to subtract 30 from that. So that gave me an answer of 24.7. So that clearly is greater than 0. So this point here is the minimum. So we can do the other one, but clearly that's going to be the maximum, because if one's the minimum, the other one has to be the maximum. But we'll just double check. So 6 open bracket multiplied by 5 minus root 17 minus 30, and doing that will give me a solution of the following. Just put that in the calculator, and that gave me an answer of negative answer of about negative 24. So that's definitely negative, so that's greater, that's less than 0. That's our maximum point. So that's basically done. We know our minimum, we know our maximum. The question wants the coordinates. So you take this, you place it back into the original formula for each one, and you get your points. So first point we're going to write is 5 plus root 17. So we need our y value. So we go back to the first original formula and place in our y value there. So 2 open brackets 5 plus root 17 all cubed, okay, minus 15 open bracket 5 plus root 17 all squared, and plus 24 times 5 plus root 17, and lastly plus 6. So the answer would give me 495 point something something, and the other value we do the same thing with 5 minus root 17, and we do the same thing for that solution, and you write your solution down there. So you make sure you label this as the minimum and this as the maximum. So that's how we do this. Okay, we differentiate first, we make it equal to 0, we find our stationary points, then we do a d2y dx squared. It's actually checking if it's a maximum or minimum. We put it in and see if it's greater than 0, it's a minimum. Okay, if it's greater than 0, it's a minimum. If it's less than 0, it's a maximum. But if you have 2 points to check, technically you tend to have only 2 points in A level. So check the points. If you know one's minimum, the other one has to be maximum. But just do it for, for the examiner to see, and that should be it. Okay. Let's look at this now. We have another exercise, again new for some people, not new for other students. The question is asking us to look at the value that we have here. It says the diagram shows the curve of the equation y equals f of x. The curve has stationary points -1 and 4 and 1 and 0 and cuts the axis at -3, 0. Okay, so what that means to us is when we find dy dx, we're actually finding this value here, okay, and this value here, because finding the differential dy dx gives us the stationary points. Okay, the stationary points. What that means is it finds the minimum and the maximum. So if they want us to sketch the graph of y equals f of x, we only sketch the points of the minimum and maximum. So the minimum here is -1, and then here the other one is going to be 1 also. So we have 2 points to plot. Okay, we have 2 points to plot. Just do that again. Okay, again, when we are doing a differential dy dx, what we're doing is we are looking for these points. Okay, we're not interested in these points, we're looking for the stationary points, the points where we make the minimum and maximum, where the gradient is 0. And finding that, we are looking for the x values. So obviously that x value would be 1, 0. So that x value would be 1 and that x value -1. So we've got -1 and 1. And it's a matter of just drawing a curve. And that's our point. The examiner is looking to see your x value and y value, and that's it. Let's try a different question. Let's say we have a function goes like this, and we have this point is -6, 3, and this point here as being -1, -3. So if we're told to sketch f of x, so we're looking, we'll get the -6 and we'll get the 1. So we show our curve cutting at -6 and 1. Don't worry about the y-intercept. And we just draw the lines, make sure it goes through them all, and that's it. Okay, that's all you have to do. Unfortunately, A-level questions can get difficult, so you have to prepare yourself for all type of questions. So let's look at this question now. So this question is a bit more complex, but again, it's not that complex as you think. Okay, we're looking for, again, the minimum point. The minimum point is here. Okay, it's right here, which means that we will ascertain the point. Okay, we'll ascertain the point. So to sketch such curve, we know that we need to cross it at -3, because that's our x value at the minimum. So -3. We're also going to do the following, is to draw the curve so that it goes through -3. Okay, goes through -3 and then does this. So we're basically flipping it over, but forcing it to go to -3. So the idea is our examiner will see -3, and also we can see clearly our graph is not going to touch the x. So our asymptote here is going to be technically y equals 0, because it's not touching that line. Okay, again, we looked at minimum, we plotted it. Okay, it's just really learning that minimum plot. Okay, let's look at a different question. Let's look at these. So here we have 1, 2, and 3 points. 1, 2, and 3 points. So that means we're not going to have a quadratic, we're going to have a cubic, because you have three minimum points. So let's first place the minimum point -9. Again, we're looking at the x-axis only, and this point is 0, 0. We know it's going to cut at 0, 0. So let's move this a little bit. Let's redraw this graph so it's not so it's heavy on this side and short here. So -9, 0, and 6. So the curve is going to go through -9, coming like that. Okay, go through this point, and then go through this point. So it goes through the minimum points and the maximum points. Okay, let's do that again so you understand. Again, when we're finding f of x, okay, we know that we need to look for the x values, -9, -6, and 0. So 0 is here, so let's say -9 is here, and 6 is about there. So we're going to go through this point first, and then through the point, which we can see here. Something that students ask is look at the point. So if this curve is starting to come from here, the hint is it's gonna come from the top. Okay, so it's gonna come from the top, and it's gonna go down through this 0, go up, and then go through 6. Okay, so let's look at B now. Let's look at B. Okay, let's look at B. Let's drop this out. So B, where is our point of B that we need to take into account? The point that we need to take into account here is we don't really have a minimum maximum here. Okay, it's difficult to find it anyways. So all we're going to do is flip it. Okay, we're going to flip it because that's technically what we're doing. So we're doing this, and the reason why we do this is because you'll understand it in A level, A2, if you study A2, because when you do y dx of something, so when you differentiate 1 over x plus 1, okay, or integrate 1 over x plus 1, you get a log graph. Okay, and differentiating a log graph, you go back to a exponential. So this is something you'll do next year, but it's important that you have awareness of it. Okay, let's look at the question D. This one here is better because we have a minimum point, we have points all around, so we can do this one. So straight away you're going to plot the -2, and you're also going to plot this point here. If you look at the coordinate, it's 0, 6. So this point is going to be about here, -2 is going to be about here. So now all we have to do is plot this line. So we're going to go up, okay, through this point here, and throughout there. No, sorry, I do apologize. Going through here, going through the point, and going through there. Okay, so you can see the curve. It's asymptotes on that side, and asymptote here is going to be the line of x. Finally, we'll look at this point here, guys. So this point here is not that hard actually. Now you've looked at a lot of ones, so the first one's not going to really change. Okay, first one's not going to really change. The second one is where we are going to basically flip it, and we're left with this. This again is not really examined a lot. I think you'll get more of these ones, the easy ones, than these, because these come in A2. Okay, you'll see them. They don't tend to give this a lot in exams. Okay, so the last thing that you have to learn for this module is modeling with differentiation and what I call optimization. Okay, so this can be hard, but it's not really hard. It depends on the question. Every question is different. So think back to, don't overthink the question, underthink the question to a certain extent. So let's look at this shape, this one right here. So it says the given volume of an expanding sphere is related to its radius r by the formula. So they've given us a formula, v equals 4 over 3 pi r cubed, which is nice of them. They don't tend to give you that. find the rate of change of volume with respect to radius at the instant. So find the rate of change. Rate change is going to give, basically, it's going to be differentiation. So that means we are going to do dv this time over dr, because we are doing the change of volume over the change of the radius. So let's differentiate this. So when we're differentiating, we take, again, pi is a constant, remember that. Okay, remember that pi is a constant, and when you differentiate pi, you get the solution. So this would all be, again, 3 times 4 over 3 pi times r squared. So we're keeping pi as a number and we're not really converting it. The 3 will cancel out with the 3 and we're left with 4 pi r squared. So dv over dr now is 4 pi r squared. So it says find the instant when the radius is 5 centimeters. Find the volume. Don't want to respect the word. So find the rate of change of volume. And so now all we're going to do is place r in here. So 4 times pi times r, which is going to be 5 squared, that will give us 100 pi. And that will give us the volume at that rate when the sphere is r